Hi, how's it going? So at the moment we've got this triangle and right, so seems to be fine, it's got texture and stuff, but what if we want to make a more I just realized I forgot or accidentally got rid of this line, so we should probably put it back in. Okay, so where were we? We've got this program and it works. Okay, and I just found another error where I begin single time commands. This allocation info must be set here. Let me try that again. Okay, now also the image extent needs a depth of 1. I think 1 is a default anyway, but if that's not set, then it'll throw an error. Okay, cool. So that's just fixing up a few mistakes that I glossed over last time. So that was in copy buffer to image, we need to declare the extent to have a depth of 1. Okay, so we've got that app and it works. But what if we want more complicated geometry? Let me just paste this in. Actually, before we do that, let's just look at the Vertex Shader. So what if we want to work in actual 3D? So for position, we'll take a 3-dimensional vector. And we won't automatically set the Z to 0. We will work with whatever is passed through. Now I'll paste this in. So what I want to do is I want to create a cube and I'll define the vertices like this. So that is X, Y, Z for positions. Oh, right, and of course, for the vertex structure, that will be position there. And here, we'll need to reserve another 32 bits. So that should be okay. Change the index buffer. Okay, cool. Now we'll just recompile the shaders. Give this a shot. And it's a little strange. So it's supposed to be a cube, but things are drawing in kind of a random order. Well, not a random order. Things are drawing in the order that they have been declared, instead of by depth. So we need to include a depth buffer. Okay, let's go ahead and do that now. One thing we'll need straight away is GLM is meant for OpenGL, where depth goes from -1 to 1, but we don't want that. Okay, cool, so we've got that. We're gonna, because Vulkan uses depth between 0 and 1, we'll force that on GLM. And then we want to, where are we? I'm going crazy. We want to create a depth buffer. This is actually very similar to the texture image. Yeah, so we need, actually we don't need that, but we do need, yep. Okay, so we need an image for our depth buffer. We need memory, of course, to draw to, and we need a view to be able to access the depth buffer. So what the depth buffer is basically an image which is reused every frame. It's drawn to and then read from and used in depth tests. So if we go down here, about here, I guess we start creating our texture stuff. So we'll make a function to create our depth buffer, and we'll do it all in one. And we'll put that implementation down here where everything else is. Now there's just another two functions we're going to need. We could just, okay, so a depth buffer is an image, but it has a specific format where some of it is the depth component and some of it is a stencil component. It's usually called a depth stencil buffer. Now we could just hard code in the format that we want to use, but it would be kind of cool and kind of fun to query the device and see what it can support. So I'm going to write two functions here. First one is find depth format. So I haven't implemented this function, find supported format yet, but hopefully we can see from the way I'm calling it. What I'm doing is I want to pass in a list of formats in order of preference. So this would be my number one preference, and then going on and on. And then I also want to pass in the tiling mode. I'm going to use optimal. And then I'm going to pass in the usage. Okay, so then we need to create a function which takes the formats we're requesting as well as the tiling mode and the usage, and it queries the device and returns the first appropriate one. So we'll go ahead and code that up now. Okay, so here's how it works. We look through all of our formats that we've passed in. We check our properties of our device, and we check if it matches. So if we're looking for one sort of tiling, then we also check for that tiling within the device and see if that's supported. Remember, we're doing bitwise and in order for this to be equal to the original features, then everything here must match everything in our requested features. So this pattern is kind of similar to the find memory type, which was used earlier in a previous video. Anyway, so the point is we just search and return the first thing which is acceptable. Okay, so now let's go back to the depth resources and we'll use these functions. Okay, took me long enough. So we have that set up, we've created our depth image and allocated the memory. We then need to create a depth image view. But there's a bit of an issue here. So if we go to our general create image view, should be somewhere here. Then by default, we are always using the color bit of an image, but that may not work for us. So in this case, you want to use the depth bit. So what is this? This is, so for instance, if we pass that in there, then that works. We've got that set up. But you may notice down here we have some errors because the previous time we called these functions, we did not have that extra thing. So what is this? Line 668. Okay, so we need to specify that we want to use the color bit. Cool. Then line 1356. Okay, so we are good. Now just while we're at it, we can duplicate this destruction code. Okay, but then the question is, how do we use this stuff? Okay, so the first step in getting this actually used is we go to render pass, and let's generalize this a little bit. So this is going to be our color. Then we'll set up our depth. Okay, so format. Depth will be attachment number 1. Okay, then we'll grab all of the attachments. Okay, so you might be looking at this and saying, hey, why do we define a color attachment count but not a depth stencil attachment count? And why is this color attachments and this is singular attachment? Well, that's a fair question to ask. A frame buffer, a render pass, may have multiple color attachments because we might be writing to multiple textures at once. However, or reading from multiple textures. However, we will only have one depth stencil buffer, so this is just set up as a straight up reference. Okay, then we go down. This is all well and good, but here where we say attachment counts, we want to generalize this. And that should be fine. Yep, so this render pass is created and kind of depends on the depth attachments. We need to make sure that we are creating our render pass after we've created our depth stuff. And then this create graphics pipeline. Well, the graphics pipeline depends on everything else pretty much. So this also needs to be after the render pass because it references the render pass. And hopefully this works okay. Might be a good idea just to run it. It won't work, but at least see what the errors are. Okay, so it seems that frame buffer requires a render pass. Okay. So this is just playing around with these, changing the order of things. Hopefully I've got that right. Let's try. Yeah, no, that's fine. So this is saying that we're defining one attachment for our frame buffer, whereas 2 attachments for our render pass, and that's perfectly fine because we haven't touched the frame buffer yet. So let's get into that. Okay, that's fine. It's kind of what I expected. So create frame buffer is okay. We now need to look at create graphics pipeline. So here we've got our color attachment. That's fine. Let's create. Probably not much point copying that stuff over. There won't be a lot of similarity, but that's fine. So we set this up to do depth testing, and the way this works is a depth of 0 is at our eyeball and a depth of 1 is far away. So the compare operation, we want to keep a fragment if its depth is less than the existing fragment in the position it's drawing to. In other words, if it is closer to our eyeball. So we set compare op less. Now what this does, depth bounds, is we can specify like bounds we want to work within, but we're just going to set that to false. It's a pretty simple scene, it's fine as it is right now. And then the last thing we're going to do is we're going to disable the stencil test. Because a depth test is, a depth buffer is like depth and stencil information packed in together. We're not going to use the stencil information at this point. Okay, so then we go down here, and this depth stencil state. Set that up, that looks fine. Okay, that's fine. See, nothing's being written to the screen and it's complaining that the clear depth value is something strange. That's fine, it's just because we haven't set this up. So remember, oh yeah, don't do that. By default, when I hit Control S, the cursor is down here and it tries to save the output of the debug window. So the next thing we need to do is go to our command buffer and set it up so that in each frame it clears the depth buffer. Okay, cool. So this is a little bit funky here. We have got 2 attachments, so we need 2 clear values. However, the first attachment we're only going to be clearing the color, and the second attachment we're only going to be clearing the depth stencil. So we clear the depth to 1, which is like clearing the depth to infinitely fast, so everything will draw back on top of that. And then stencil is 8 bits, so that goes from 0 to 255. We're just going to pass it in 0, we're not using that information. Wow, and there it is. And as you can see, hey, it's not quite working right, but that's fine. You see, when I created this, I intentionally swapped the order of the vertices so that faces would be drawing. For instance, look at the bottom face of this cube. This is supposed to be facing down, and it should have the vertex order set that way. However, if it was facing down because of the backtest, it would never be drawing, and I wanted to show how it drew on top of other things. So, long story short, this works, and to get it drawing properly, go right back up the top. Okay, so the top face draws properly, the bottom face needs to be reversed. So what I'm doing is I'm swapping these outer two values, so 4, 6 becomes 6, 4, and so on.
Front is fine. 13, 12. 12, 15, and then 18, 16. Oh, wait a second. That one was actually fine. And this is 12, 15. Okay, fingers crossed.
Nice. Cool, so that's it. That's how we can get depth buffering working. Hope you had fun, and see you next time. Alright, bye.